Problem number 5 says Isabella surveyed 5 of her friends to find out how much each earned by tutoring last month. Use the clues provided to find the 5 amounts earned. So let's go through each one of these clues. You don't always use the clues in the order they're given. For example, the first one says the median is the most appropriate measure to use to describe the responses, and I can't do anything to figure out any of the numbers from that, but what that does tell me is that there must be an outlier in the data, because if the median is the most appropriate measure, then the mean is not appropriate, and that happens when you have an outlier. We talked about that in class. There's some very high or very low number that's dragging the mean to the high or the low end. So that could be useful once we start to figure out some of the numbers. There is no mode, so none of these amounts occur more often than the others. I can't start to figure out the amounts from that either. The sum of the 5 amounts is $250. Okay, that doesn't help me find what any of the 5 amounts is, but I can definitely do something with that. If the sum of the 5 amounts is $250, then the mean must be $250 divided by 5. So the mean is 50. And then the very next clue tells me that the mean is $20 more than the median. So if the mean is 50, and that's 20 more than the median must be $20 less than that, which is 30. So 50 equals the mean, 30 equals the median, and I can also start to write some of the numbers now that I know that, because there are 5 numbers. The median is 30, and there are 5 numbers. The median is the middle. So at least I know one of the 5 numbers. I also know that if there's no mode, that there can't be another 30 here or here. The person who earned the most, this person, made $140 more than the person who earned the least. So I don't know how much the person who earned the least made, so I can't really do anything with that yet. All of the responses are multiples of 10. Now we can definitely do something with that. Multiples of 10 are 0, 10, 20, 30, 40, 50, 60. Any number that is multiple tens. So this could be 0. Most of the time when students do this puzzle, or certainly I should just speak for myself, when I first did the puzzle I wasn't really thinking about 0 as a multiple of 10. So I just put 10, 20, that's 30, so that all fits this clue. And then I know the person who earned the most made $140 more than the person who earned the least, so $140 more than 10 would be $150 for this person. And then you can use the clue that tells you that the mean is 50, or the total is 250 to figure out this missing number. So far we have a total of, there's 50 here and 150 here, so that's 200, plus this 10 is 210. So 250, having some trouble here, this pen, that makes that 40, and that fits in with this multiples of 10 clue, and there's no mode, no number is occurring more than the other numbers. There are 2 other solutions to this puzzle though. If we go back to where we started, where we knew the median was 30, and keeping in mind that the lowest number could be 0, I should really change the puzzle to say positive multiples of 10, but I kind of like the idea that there can be more than one answer here. Now this one can be 10 or 20. Let's make it 10, and let's make this person who has the most 140 more than the person who made the least. So 140 more than 0 is 140. And then we use that same idea to figure out the missing number, 250 minus what we have now, which is 180. So that makes this number 70. Or we could have gone with 0 as our lowest multiple of 10, 30 as our median, and gone with 20 here. So 0, 20, 30. This is still 140. And now we have 50 and 140 is 190. and 190 and 60 gives you the 250. So any one of those three sets of numbers solves this puzzle. On your review on page 2, the scatter plot shows the results of 8 students on their last 2 algebra tests. Which of the following is the greatest change in scores from test 1 to test 2? So this was a problem that was taken directly from SAT test prep materials. Again, the SAT test is a test you'll take in your junior year of high school. This is test, that was a bad choice of color there. This axis is showing us test 2, this axis is showing us test 1. And so the points on our scatter plot represent 2 test scores. Each point represents 2 test scores. This point represents a student, and that student got a 40% on test 1 and an 80% on test 2. So the question is, which of the following is the greatest change in scores from test 1 to test 2? So to find the change from test 1 to test 2, we'll subtract. We'll do test 2 minus test 1. So this student's score on test 2 is 80, and 80 minus 40 is 40. And I'm just going to put their change right next to their point on the scatter plot. This student improved from a 50 to a 90, and that's also a change of 40. The student went from a 60% on test 1 to a 70% on test 2, so that's an increase of 10. This student went from a 70 to a 90, so that's an increase of 20. This student scored 80% on test 1 and 100% on test 2, so that's an increase of 20. This student down here scored 80% on test 1 and then actually dropped down to a 60% on test 2, so that's a change of a negative 20. This student I'm second guessing something now. Which of the following is the greatest change in scores? We're going to get into a little bit of semantics here, and okay, we'll talk about that in just a minute. This student got a 90 on the first test and dropped to a 40 on the second test, so that's a change of negative 50. This student earned 100 on the first test and 70 on the second test, so that's a change of negative 30. Now, the greatest value here are the 40s, because 40 is greater than any negative number. But when we say change, we're talking about independent of the direction. So this student's score changed by 50%. The difference is negative 50, but the change is a 50% change. And so you really need to be thinking about the absolute value of the change. And so the student whose score changed the most would be this student, and it changed by 50%. Okay, problem number 7. Howard takes 5 tests. Each score is a whole number between 0 and 100 inclusive. That means the score could be a 0 or it could be a 100. The following statements are true. The mean of his scores is 80. We can do something with that right away, right? There are 5 tests and the mean is 80. Then the total amount of the 5 tests, if you added up all the points, would be 80 times 5 or 400. I'll just write that on the side. We might be able to use that later. The median is 81. Well, this is a lot like problem number 5 in the way that you can start, because if there are 5 tests, 1, 2, 3, 4, 5, you have a middle number. And if you know the median is the middle number, so that's 81. There is just one mode, and it is 88. If there's a mode, then there have to be, since I have an 81, there have to be at least 2 88s. And since we would show these this list of data from least to greatest, the 88s must be here and here. There have to be at least 2 of them, and this is the only place they can go. So these 2 numbers have to be different, otherwise we would have 2 modes. Find the least possible score Howard could have received on any one test. So the least possible score will go here. But how am I going to find that when I don't know this other number? The key here is in the word least. There are many combinations of two scores that you could put here. Not an infinite number of combinations because these are whole number scores, but there's some long list of pairs of scores that would fit in here that would be lower than 81 and would still combine to give you this total of 400. But we don't care about every possible pair. We care about the pair that gives us the least possible score in this position. And in order to have the least possible score in this position, we want to maximize the score in this position. I think there's a better way to explain this. Let me try something else. If I start thinking about this total of 400, and I look at what I have so far, I have 88, 88, and 81. So 80, 80, and 80 is 240, and this is 17 more, so this is 257. So I have 400 minus 257 is, I'm not doing standard algorithm, I'm just thinking what can I add to 257? 143. So these two scores have to add up to 143. I could do that with, I don't know, 70 and 73. I could do that with I'm trying to think of some that I could that won't throw it over. 70 and 73. I could do 71 and 72. There's lots of pairs that could fit in here. But in order to make this as small as possible, well, let's look at what I just said. 70 and 73 add up to 143. 71 and 72 add up to 143. So as I increase this, as this number gets bigger, this number gets smaller, because the pair have to add up to this given sum. So with that in mind, if I make this one as big as I possibly can, that will minimize this one. And what's the biggest I can make this number? I can't make it 81, because even though that would still be least to greatest, then I would have two modes, and we only have one mode, and it's 88. So the maximum for this number is 80. And if that's 80, and these two have to add up to 143, this must be 63. So 63 is the answer to number 7. Okay, we'll pick up the review with problem number 8 in the next video.